Hi, my name is Eduardo Trujillo, and I'll be speaking about the individual models that we use and the stacked models that we tried in order to obtain a better weight F1 score. So these are the individual models that we use: logistic regression, k-neighbors, SPM, random forest, and gradient boosting. So these classifiers are used for binary problems. We do have three classes: low, medium, and high. The way I got around this problem would be by using a classifier called one versus rest classifier. So these are used for individual models for tuning their hyperparameters. So this classifier, one versus rest classifier. So it involves splitting the multi-class dataset into multiple binary classification problems. So a binary classifier is then trained on each binary classification problem, and then predictions are made using the model that's the most confident. So this was just done to better tune the models. So the non-tuned models here, uh, we have values like around 50, high 50s here, 60 at the bottom here for random forest gradient boosting. When tuning the hyperparameters, it increased for a few points, like in general. For example, 56 went up to 58, 57 to 59, 57 to 58. So not much of a difference, but still just a few points based on the values that we tried. So after finding slightly better uh, hyperparameter values, then we try to experiment with stacking, and this is the best stack model that we came up with. Uh, some of the things that we did, like before finding the best stack model, would be just experimenting and then rotating classifiers. So for example, SPM instead of being layer 1 will be the final estimator, and then random forest would be the final one, and then gradient boosting and so on. And the same thing with from layer 1 to layer 2, and just basically just trying different combinations. So this is the backstack model. So we use the training data. The first layer would be SPM, random forest gradient boosting. We made predictions, and then logistic regression was the final estimator. So the performance metrics. So these are the performance of that final stacked model. So we can see the weight average for the F1 score increase by 2 points when compared to the best individual model, which was random forest and gradient boosting. So 0.6 to 0.62, so it was slightly better. And that was the goal, to get a better F1 score. Even though tuning the default values got us just a few points better, it was still an improvement. And then just stacking also the models got us a few points better. It was still improvement. So it was a slight improvement, and this is the best model that we came up with.